Sievert. Carson is a software engineer with our studio, bringing us really good things in terms of data analysis and visualization packages. Carson has a PhD from Iowa State and is a Chamber Award winner. Chamber is award winner for his work with Plotly. That's an ASA granted award. Before he started working with our studio, he was a consultant at the Library of Congress and NOAA. That's the other people, not the art people. So Carson's going to talk about reproducible shiny apps, and this is work he did with Joe Chang. So, Carson.
Great. Thank you for the introduction, Brian. I assume everyone can hear me okay? Yep. Good. All right, so yeah, I'm really excited to be here and share some very recent work that I've been doing with Joe Chang at our studio. So just by a show of hands, how many people here have programmed their own Shiny app before? Okay, pretty good, so about half of us. So if you've programmed a Shiny app before, you probably know that Shiny makes it really easy to turn your R code that generates some sort of results or an output and wrap some code around that to make an interactive graphical user interface where users can then quickly explore different variables, different values, different parameters, different information in general. So I want to show you this real basic Shiny app here where I just have a drop-down where I can choose a different variable from the Diamonds data set. And then every time I change this drop-down value, a new bar chart or a histogram is displayed in the Shiny app. So on the left-hand side is the actual Shiny app, but on the right-hand side is the code for the Shiny app. So just really quickly, I want to sort of, in a nutshell, tell you how Shiny works. In this code here, you can see that there's two main components to a Shiny app. One, the user interface, that's this UI object here. So the user interface for this basic Shiny app just has two components. It has a Plotly output, which is going to sort of be the container for this histogram, and then a select input, which creates the drop-down below the histogram. So notice with this select input, I've attached that to an ID of X. And what that allows me to do is on the server side, I can then, in what Shiny calls a reactive context, which is this render Plotly statement, I can access that input value by saying input $X. And every time this dropdown changes, basically this R code is going to be rerun. That's why it's being highlighted in yellow, where basically it's going to, the input $X is going to take whatever the current value of that dropdown is, grab a column from the Diamonds data set, and give it to Plotly to create a histogram. Right, so a lot of us probably know that Shiny is really great for sort of easily enhancing your sort of workflow with interactivity, but this is going to come at the cost of reproducibility. And this is sort of a universal problem in software. The more interactive your software is, the harder it is going to be to actually reproduce whatever you did in that interactive software. So up until this point, we've basically had two options if we wanted to reproduce results in Shiny. So say you have your Shiny app and you find your variable of interest and that generates the histogram. Really, the only way to replicate or reproduce that result is to go into the Shiny app and then replicate whatever events that got you to that point. A few years ago, thanks to Winston Chang, who will be talking in a couple hours, Shiny now has a bookmarking state feature where you can basically save a URL to at some point in time, you could go to this URL to go to that same state at which you were at in the Shiny app. But still, with these two options, the results are still sort of locked behind a graphical user interface. You can't easily sort of extract your methodology or domain logic that you've embedded in your Shiny app and sort of take that into a different workflow. So, but even if you're, interested in knowing like what is the actual methodology or the domain logic that's embedded in the Shiny app, even if you can go to the app source code, that domain logic is now sort of intertwined with Shiny's reactive sort of framework. So this is going to make your methodology that you care about embedded in this Shiny application less transparent, and it's going to make it harder to verify that the results that this app is generating are actually correct. So this has been a sort of a problem in the field of pharmacology. There's lots of people using applications, lots of managers using applications to like find something interesting, but sort of this reproducibility factor is something that's very important to them, where they need to be able to replicate with code essentially the results that they're finding in their Shiny app. So sort of the holy grail that we're trying to reach here with Shiny is to have both the interactivity, the nice interactivity features of Shiny, but then also at some point in time be able to export the domain logic that's powering, like, basically give me the R code that can replicate the stuff that you see in that Shiny app, and allow me to run that code outside of this Shiny application, just in, say, a new R session. So that's kind of the goal that we're trying to reach here. So I want to show you an application could work using an application that's designed ANOVA analysis, and then basically download a reproducible report of their analysis that they've done on the Shiny app. So hopefully you can see this, but I'm going and uploading a CSV, and then I'm choosing a response variable for my ANOVA analysis, and then choosing two predictors. And then I can go and check the normality of my response, make sure that, you know, the assumptions that I'm making for this ANOVA analysis are actually, you know, reasonable assumptions. And then I can go in and define my formula for my ANOVA, run the ANOVA analysis, get my table of results, my test statistics, your usual ANOVA output, and then there's an option for making pairwise, multiple pairwise comparison corrections. But then notice I have this button to download a report. I get a zip bundle with an HTML file, which I can then open, and this is completely independent of the Shiny application with all my results, basically with the data that I've uploaded and all of sort of the methodology that I've run on this data, the results and the actual code used that I could use to basically reproduce all of these things outside of Shiny. So not only do I get this HTML report with the results, but I also get an RMD file with the methodology inside of that RMD file that I could then run at any time that I want and not have to rely on the Shiny app at all. So this kind of highlights at least 3 or 4 really nice benefits. Like why I'm sort of trying to motivate, because we're going to have to do some work to get a Shiny app to do this sort of thing. I want to motivate, you know, why you would actually do this in the first place. And the first sort of general one is you can enable your users to verify and extend your methodology. So if I can easily get at, you know, the ANOVA, you know, the code to run my ANOVA analysis, that allows me to sort of learn, like, whoever programmed this application, you know, has some knowledge about how ANOVA analysis works. I can sort of download that methodology and take it into my own work and extend it if I want to. And then I think there's also some connections to what Amelia was saying earlier this morning, where could be some interesting applications here where if you design a graphical user interface to sort of teach a statistical concept or teach people basically how to do data analysis in a graphical user interface, but then they're able to actually get at the code behind what's making all of this work, it sort of helps them make that connection that, you know, I could actually write code to do the same things that I'm doing in this graphical interface. And then this third one, I think, is related to being nice to yourself in terms of, if you were to do a workflow like this, like upload a data set, run an analysis to get your results, but then 6 months from now, you need to come back to that work that you did via graphical user interface, you might be shit out of luck in terms of knowing exactly what you did to get that result. But with this sort of a thing, you have a record of what you did exactly to get the results. And then this is another nice thing, this idea of permanence, or the fact that I can download an artifact that's standalone from the Shiny app. I can save it locally on my machine, and I know that if that Shiny server ever goes down, or the Shiny developer changes some of the features, I still have those results that I can come back to at any time. And then this last one, this is an interesting sort of application when you think about Shiny apps that use data that change over time. So if I have sensor data that updates every day, or I'm interested in stock quotes, or have some database that users are filling data into, I could go into my interactive app, find something interesting, but then get the logic that's embedded in that application and sort of have something that I can run at any point in time in the future, so that I could basically get the same analysis with new data. And I want to show you an example of how this can work. And I'm actually going to locally demo this instead of showing you a video. Bear with me for a second. All right, so the idea of this Shiny app is you can go into this input thing and search for an R package that you're interested in. Say, I want to know what the download statistics are from CRAN for, say, Plotly, which is a package that I work on. And say I want to compare that to Shiny. I'm just going to remove these other two quickly here. Zoom in so you can see this better. So this application basically queries some API service to get the daily download statistics for any sort of R package that you're interested in. And then I could look at the daily download statistics. I could apply some transformation to that, like a weekly rolling average, to reduce some noise in this time series. And then when I'm sort of happy with the results that I've landed on, I can click this download report button, which you can see this progress bar showing me that's rendering a report, and it'll eventually give me a zip bundle here, which I can open. And I get 3 different files in this folder, one of them being this HTML file. So this HTML file basically has that output that I was interested in from that Shiny application. And there's also the source code for reproducing that plot outside of Shiny. So I could actually copy and paste this code and run it in a new R session, and I would get this same plot again. And another nice thing about this is I get the RMD file. So here's basically the R code that I could run outside of Shiny to create my graph. And what I could do with this is publish this to RStudio Connect or some other service. And I'm not actually going to publish this because I already have published it. But here is that published RMD report on RStudio Connect. And one of the nice things about this is that I can then schedule this RMD to run at whatever time schedule I'm interested in. So say, like, this data will update every day. So I could schedule this to run at midnight every night. And RStudio Connect will run this report. And then I have the history of all the times that I've run this report. So the sort of, I don't know why this is not rendering now, but so the idea is, once you have that, use the application to find the packages that you're interested in, but then you can schedule this to rerun with these same results with dynamically updating data. Right. Okay, so hopefully I've provided the motivation to do this in the first place, but how do we actually get a Shiny app to be generating reports like this with reproducible code? So there's a few ways actually to go about this, but we've been working on this, our package called Shiny Meta. And if you saw Joe Cheng's keynote at USAR 2019, a couple months ago, his keynote was about this package. And I just want to forewarn you that we still consider this experimental. We're making breaking changes. If you go and watch his talk on YouTube, you'll notice that we've made breaking changes from his talk, and now I'm going to show you something slightly different. But I think we're sort of converging on something that will work well. So it's not yet, this package is not yet on CRAN, but you can install it from GitHub currently. So to show you how this works, we're going to sort of boil that CRAN View app down to a more basic version, where we're just going to have a text input where you can enter in our package name, and then you can get that weekly rolling average time series of the downloads for the past year for the given package. So, and I want to boil this down because I'm going to show you the source code for how this app was implemented. And I'm going to show you how we can sort of modify this in order to get this app generating the code to reproduce that plot that we see in the application. So again, with the Shiny app, there's two main components, the user interface and the server functionality. The user interface is really straightforward in this case. There's just a text input where you input the package name and then the plot output, which will hold that time series. And then to get at the actual download statistics, I'm going to create this reactive that I'm calling downloads, which will use this CRAN logs package. There's a function called CRAN_downloads, where you can give it a package name and 2 different dates to get the downloads between those 2 different dates. So I'm just going to give that basically the value of this text input, and then get the downloads for that package for the past year. Right? And then the next part is going to be basically computing this rolling average part. And notice in this downloads rolling reactive, the first line that you see there that starts with validate, this is about, basically this is there so that if the user enters a package name that doesn't make sense, we can show them a nice message. We'll show them basically, please input a valid package name, rather than getting some other error that probably doesn't make much sense to the user. So this is, something that we call in Shiny, we call it input validation. But if we've met that criteria, assuming that we have inputted a valid package name, then I can call for the value of downloads, which is a data frame. So then I could use dplyr to dplyr and this zoo package to compute a 7-day rolling average of these downloads, just to sort of reduce some noise from this time series. And then finally, when I create this plot, I can call downloads rolling within a rendered plot context and feed that into a ggplot visualization. Right? So the first step to sort of getting back code that can reproduce this plot, the first step that we need to do is, oh, I actually went ahead of myself here. But yeah, this is just basically showing you the goal that we want to enable. We're first going to get the code to reproduce this plot and just show it in the Shiny app like this so that you could copy that code and run it in a new R session to get that plot outside of the Shiny app. Right, so here's the implementation again. So the first step is to identify what is the actual domain logic that we want to export from the Shiny app in order for it, to make sense for the user and so that I can run it outside of this Shiny session. So really the main core parts here is this call to this CRAN downloads package or CRAN downloads function. And then the computing of the 7-day rolling average. And then finally this ggplot2 code. So once we've identified the domain logic, you're probably going to be left with parts that appear within a reactive expression that doesn't really make sense to export to your user. I don't need to export this input validation because the code that we're going to be exporting is probably going to be a valid package. So this is really code that only really makes sense for the Shiny runtime, but I don't really want to export that code to users because it's not going to make sense outside of the Shiny application. So once we've identified this domain logic, the next step is to capture the domain logic. And we do that using what I call meta counterparts to Shiny's reactive building blocks. So notice that the downloads reactive has now become a meta reactive, and this is a function from the Shiny meta package. And also, let's skip over downloads rolling for now, but if you look at this meta render part here at the bottom, notice that these like a render function like render plot must be wrapped in a meta render. I guess it would be nice if you could just say meta render plot, but package developers can define their own render functions, so we basically need to have a more a general way of making meta versions of render functions. So it's slightly different in the sense that you just don't prefix the name with meta. You need to basically put your render function in the first argument of this render function. But yeah, you just have to live with that. And then for the downloads rolling part, notice that I'm not using meta reactive, I'm using meta reactive 2. So this has a slightly different functionality than meta reactive in the sense that it's basically going to ignore any code that appears outside of this meta expression that I've also put inside of this reactive. Basically, this is our workaround for giving you control over ignoring like the Shiny specific code that you don't want to export when you go to generate code from this application. So yeah, just remember that with this meta reactive 2, you can ignore code, but then wrap the code that you care about in this meta expr function. Right, so then the next step is to identify what I call reactive reads. So this is going to include any references to input values like input $package, but then also any references to calling for the value of a reactive expression like downloads open parentheses, close parentheses, or downloads rolling open parentheses, close parentheses. And what you want to do with these is you're going to have to mark these reactive reads with something we're calling the ... operator. And we'll see what happens when we actually go to generate the code in a couple minutes. But sort of the idea here is that by marking these reactive reads, Shiny Meta will know what to do in the sense of sort of substituting like input $package with whatever the current value of that input is at the time. So that's kind of the reason why we need to mark these things. And then also notice that the dot operator has some connections. If you're familiar with rlang and this bang bang operator, there are some connections there where you can use this to, if you've ever heard the term unquote, it means that when we generate this code, I can return the value of this expression instead of the expression itself. So that when this code is exported, I can essentially like hard code the date instead of having it being like a dynamically updated date. We'll see that in a second. And then really the last step is to use this expand chain function. I hate the name of this. It's basically the naming comes from an earlier version of Shiny Meta, where this name made more sense in terms of like the mental model that you needed to use this. So be aware that this might change, but the idea is you give it to a function like expand chain. You give this like an output or a value even. You could invoke a reactive expression with expand chain. And what that's going to do when you call that function, it's going to return all the relevant domain logic that you've captured in order to get to that specific output or specific value. So it will actually, it knows enough to know, in order to create this plot, not only do I need the logic to compute downloads rolling, but I also need the logic to compute downloads as well. And this is not actually the code that it's going to spit out, but it's going to resolve these dot operators. So what it does is it resolves those dot dots to, say, include the input value, like whatever the input dollar package represents at the time that you call expand chain. It's, say my text input had Shiny in it, then it's going to replace that dot input dollar package with Shiny. And then in downstream code, it's actually smart enough to reuse the names of these other variables that you created along the way. Right, so these marked reactive reads are then substituted with a suitable name or value. And then this other dot that's being applied to sort of arbitrary code, it's not being applied to a reactive read, that code is going to be evaluated. Or another way of saying this is going to be unquoted. So that that code inside that dot will evaluate to, essentially the date that I've exported this code. And then in this situation where we're actually sort of actively working on a better solution to this problem, but you can also supply quoted code to expand chain. And we see this mainly right now as a workaround for providing some setup code so that somebody could copy and paste and use this outside of the Shiny app. Because, at the beginning of your Shiny app, you usually load libraries and maybe read in data and some other things that introduce side effects to the environment that you're working in. And sort of our solution right now is to basically like provide those library calls and other things as quoted code. And that's all I need to do to get this Shiny app at least getting at this code that will replicate this plot outside of the Shiny app. So notice if I go in and change the package name, not only does the plot update, but the code that I'm displaying in this Shiny app will also update. But this is, not the best user experience in terms of you probably don't want to if you want to enable this feature of somebody being able to get at the code that's powering your Shiny app, you probably don't want to just put it in line like this in a Shiny app. So we're going to go through some ways that we can provide a better user experience than just putting it in your app like this. Right, so currently there's really three main options. if you want to generate code that's like specific to an output, like make it so that somebody could essentially like click on an output to get at the code to regenerate that output, we currently recommend using this display code modal in conjunction with this output code button. And then if you want to get a downloaded script with the results, we also have these two helper functions that will let you download an R script or an RMD, as well as like basically creating that script and rendering the results using our markdown all in one step. Right, so here is what the output code button would look like. So you could go in and provide this button to show the code to reproduce that output just by doing something like this. And this is what downloading an R script would look like. Pretty similar to what I was doing in the CRAN view application. But instead of getting an RMD file, you could also just get a basic R script. And then here is what an RMD would look like. Basically the same thing as the downloading an R script. I guess the advantage of working from an RMD though is that, you know, you can include both like prose and quote, like provide your user some narrative around like the code that you're giving them. That's sort of the idea of putting this code inside of an RMD file. So this is what I used for the Innova app application, where if you go in and look at how that works, you know, I've basically provided some text to say like your Innova formula looks like this, and then you sort of supply variables and supply code in certain places. All right, so this is the implementation of just displaying the code inline. So you could just simply use this expand chain function to get at the code behind the plot output, and then just use something like render print, which is a Shiny function to just print whatever it is that you have in this reactive context, and hook that up to a verbatim text output in the user interface. Now, this is what it would look like if you wanted to use that output code button. Basically, you know, you don't need the verbatim text output anymore. You can just use this output code button to wrap whatever output it is that you're interested in exporting the code for. And then there's a special input variable that you can like listen to changes. Basically, like this observe event statement is saying, whenever this output code button is clicked, please run this R code, so that R code that you see in there is generating the code for this plot output, and then using this displayed code modal to sort of prompt that modal that people can then copy paste the code from. And it looks slightly different. If you wanted to enable downloading an R script, you could use Shiny's download button to just provide a download button somewhere on the user interface, and hook that up to this download handler, which is also something that's natively supported in Shiny. And then basically to do the same thing where you use expand chain to get at the code that you want to export, and then feed that into this build script bundle function. And then very similar to get an RMD bundle, but the hard part about this is you're going to have to provide the RMD template. And when you do it this way, you basically, when you create that template, you're going to have to basically reference variables in this template. So if you see this part here, this code variable, this is actually going to be like a variable in your RMD template where you're going to have like a placeholder where you reference like this code variable. And then when build RMD gets called, it basically feeds that code into that sort of template in your RMD file. All right, so I'm not sure how I'm doing on time, but kind of wrapping up here. So there's many, hopefully I've convinced you there's many benefits to having a Shiny application that can generate code to reproduce what you see in that application. And we've been working on the Shiny Meta package that's still pretty experimental, but nearing a stage where I think that we're going to be probably submitting to CRAN within the next few months. And to actually add Shiny Meta integration to your Shiny app, you're first going to have to identify and capture the domain logic. So you're going to have to do some work to look and see, like, is there any Shiny, like code that's specific to Shiny that I don't actually want to export to users? Then you're going to have to go in and mark all your reactive reads with this ... and then you export the domain logic with expand. I think all of this has been saying expand chain, but it's actually expand code now, I think. So just know that there will be one function you can use to export the code. All right, so thank you.
We do have a couple of minutes for some questions. I'm going to ask that if you do ask a question, use the microphones on your table and push the button. So, guys.
Thanks, Brian. So my question is, when you're assembling code for RMDs, I mean, Reactives they're not necessarily sequential. You can have multiple inputs that trigger what generates it. So like, is there a way you control, like, when you have an output RMD to say, you know, if there's two things that control what happens to, which one comes first? Looks like you're nodding, so you know what the question is.
Yeah. So you could actually, if you really wanted, you could use a combination of, like, up until this point recently, you know, if you go on the RStudio Shiny website for the tutorial on generating R Markdown reports from Shiny, sort of our recommendation there is to use parameterized reports. So that's how you can base your R Markdown template. But we need something a little bit more code because you can't really pass code through as a parameter. So essentially what you do is, I think I have this RMD still up. But so if you wanted to pass in some code, basically what the template would look like is you use this like mustache or like this two curly brace syntax to say, you know, when you actually go to generate this RMD source file, this code variable that I'm supplying, please, you know, insert this code variable into this place here. So if you wanted a template with multiple chunks of code, you could, you know, have also, you know, a code2 variable that, you know, say you create the code to generate one output and place it in this first chunk here. You could then create another variable to get at like the code behind another output object and put it in that other chunk there. And yeah, I guess that's all I'll really say about that. There is, I just want to point out that I put a link here, rstudio.github.io/ShinyMeta. And this is actually pretty complete packaged down website at this point. And there's a whole section on code distribution is what I call it. And this will get into like the nitty gritty of how you could actually like include prose with an R script that's generated so that you can like have more control about of the report that it's generating, as well as like some of these examples of like creating an RMD template, like with the code for one plot and then code for another plot, and how to build RMD bundle. in that case. Yeah, we have a question here.
I'm curious to hear your thinking around not just persisting or saving the code, but saving the data behind the analysis. The use case I can think of is if the data source is changing, and you want to kind of distribute the saved analysis. Is that in scope for this?
Yes, so that is something that you can do currently with Shiny Meta. There's some different ways that you can go about it. Actually, with this sort of gets into some of this, I think. But with this expand code function, there's basically ways that you can, like with that ANOVA app example, for instance, you're uploading a data set, you're doing some analysis to it, and then you're getting a downloadable report. The only way that that can work is if you're including a data file with that bundle that code will then reference. So essentially what you can do is, like, say you have your first reactive that like reads this data from the file upload functionality. What you can do in that case is there's a way to essentially overwrite the reactive expression that reads in the data, so that you can say, when I go to export this, don't give me like the file upload functionality. Just say like read.csv, this data set that I'm including with the bundle with this code. So that's a way to work around that.
Okay, we reached time. We'll be taking about a 10-minute break for passing. In this room will be Heather Lendway. She will be talking about web scraping with R. Up in 432, Christina Knudsen will be talking, we'll be continuing the Bayesian statistics introduction. So thank you, Dr. Sievert. Again, if you need to get